So we have here, let's see, v prime equals t squared over t plus 1, and then v of 0 is equal to 0. So we have an initial condition also. Let's incorporate the initial condition into the integral directly. So in other words, we will have v of t minus v of 0, that's the change. That's equal to the definite integral from 0 up to, call it t. And now we just have to switch the letter, use a dummy variable so it's more understandable. So I'm going to replace t with s. So it becomes s squared over s plus 1, and then s plus 1, and then ds. So we're incorporating the initial condition, like this 0 right here where I'm pointing. That goes in here. It also becomes a lower limit of integration. And then to get a v of t, the upper limit of integration has to be t, see? Okay, now I just have to integrate. Let's do that. So we need to divide because s squared is higher than s. So divide that on the side. You're going to use synthetic division. Okay, so draw lines. And then place the coefficients. Now we have only s squared, which means we have 1 s squared. Okay, and then 0 followed by another 0. We're dividing by s plus 1, so the root of s plus 1 is negative 1. So you put that here, negative 1. And then you bring the 1 down. And then 1 times negative 1 is negative 1. And then 0 plus negative 1 here, that's negative 1 still. And then negative 1 times negative 1 is positive 1. So you get 0 plus 1, which is 1. And now, let's recreate as follows the definite integral that goes from 0 to t. And remember, this is s in this position. This corresponds to the constant of negative 1, so s minus 1. And then it's plus 1 over s plus 1, ds. So that's the divided version of the integrand. Now let's anti-differentiate. So we're going to have, let's see, 1/2 of s squared, like this, minus s, and then plus ln, say, of the absolute value of s plus 1. And between the limits of t and 0. There you go. Notice that here, because I'm using a definite integral, there will not be a constant c at the end. It's all built into the process. So now plug in t. You're going to have 1/2 of t squared minus t plus ln of t plus 1. Just the idea across. And then when you subtract the other one, well, what would you have? You would have 1/2 of 0 squared, right, minus 0, and then plus ln of 0 plus 1. Well, if you work through each term in the brackets, copy the first ones for now. 1/2 t squared minus t plus ln of the absolute value of t plus 1. If you work through each term here, each one is 0, so it all vanishes, goes away. And that's it. There's no constant c. The fact that, for example, we want v of 0 to be equal to 0, that's already present by using v of t minus v of 0 right here. And then 0 as the lower limit of integration. It's all built in. So that solves the equation. Leave a like if it's been helpful.